For the past few videos, we've imagined objects in problems as a single point or a single particle. But real objects are extended, right? They're different shapes, things, and they don't just undergo translational motion. They might be rotating at the same time. For example, if someone was doing a backflip on a trampoline. So let me explain to you what the center of mass of an object is. The center of mass is a special point in an object or in a system. And this center of mass, the key property, and we'll label center of mass as Cm. The Cm center of mass moves exactly like a single particle would, under the same net force, even if the object is spinning or breaking apart. What does that mean? Well, the backflip dude, let's say this is our backflip dude. As he flips and spins through the air, he's moving like crazy, right? But his center of mass, it follows a perfect parabolic path while he's spinning and twisting. So here's the mathematical definition which we'll use to solve our problems today. For two particles or two parts of an object, the center of mass is equal to the mass times the position of the first object plus the mass times the position of the second object divided by their combined mass. And this works for as many objects as you want. For example, if you had 5 particles, you would do the same thing, so on and so on. Let's say the masses of the two objects are completely equal, right? The center of mass would be directly midway between the two objects. And two objects doesn't always mean two objects. It could be two parts of an object. So let's say you have a weird shaped object like that. The center of mass, let's say these two have the same mass. The center of mass is directly midway between them. For example, on a seesaw, you have two children of the same mass, then the center of mass is directly between them. Now, what if one of the children was really large? Okay, he's a bit chunky, like that. You know, we're just calling it adult. It's an adult. And his mass is bigger. Where would the center of mass be? It would lean toward the object with more mass, so the seesaw would go up. So the center of mass is closer to the larger mass, but when the masses are equal, it's halfway in between. Here's an example problem. So 3 friends go on a holiday trip and they go on one of those banana boats that you can hire. There's the banana boat, and here's the 3 friends. They are all 60 kilos each. However, their distance from the end of the raft is different. So let's say this is our x-axis. From the left end of the banana boat, friend number 1 is 1 meter away, friend number 2 is 3 meters away, and friend number 3 is 5 meters away. Find the center of mass relative to the left-hand side end. But let's use the formula we just talked about. So center of mass position is the mass times position for each friend divided by their combined mass. This is 60. This is equal to 60 times 1, 60 times 3, 60 times 5, all divided by their total mass. The answer is 3 meters. So the center of mass is 3 meters away from the left end. And this makes sense because the objects are of equal mass. The center of mass would be exactly halfway in between the two ends. What's the difference between the center of mass and the center of gravity? Let's discuss this. So the center of gravity is a single point on an object where the force of gravity is considered to be acting on it. Gravity actually pulls on all particles or parts of an object, but for analyzing translational motion, it's much easier to pretend that all weight acts at the center of gravity. So the center of mass depends on mass distribution and how mass is spread out throughout an object. The center of gravity depends on how gravity acts. So in real life, center of mass and center of gravity are nearly always at the same point. So for translational motion and involving the center of mass, we use Newton's second law. So net force is equal to mass times the acceleration of the center of mass. So big M means combined masses, so sum of all masses. And this is acceleration of the center of mass as it moves along. This is Newton's second law for a system of particles or extended object. And here's an example. It's a conceptual example, not a proper problem, but let's say there's a futuristic cargo drone of 2 bits with 2 parts, part A and part B, and it flies up into the air. But there's a scary flock of birds that attacks it. So an emergency auto separation system launches part B and A apart. Part B flies way forward, like that. But part A gets dropped straight down. What happens to the center of mass? Where does the center of mass go? Okay, if A and B have the same mass, where does the center of mass go? The center of mass, just like the backflip example from the start of the video, it will follow a perfect path as if this separation never happened. It has to be in between A and B to balance it out. Because A gets thrown straight down and B goes way further than it should be, if compared to if they stuck together, center of mass balances that and stays midway. Keeps traveling as if gravity is the only thing and there's no horizontal force. By the way, something that really helps me is having all the formulas you ever need in one place. And I make these cheat sheets for myself, and if you want your own, it's in the description for free. So go sign up.